Saya anak dia dan tak kat laptop
tahu.
kat laptop saya kat pendrive.
Alright lah.
Tak siapa tengok kan?
Sebab di sini kan?
Ya betul.
Depan. Yang sana. Ya buat ada apa?
Present di sana lah ya.
Saya nak tekan lah.
Present di sana.
Present dia free pun boleh. Free. Mic kan? Mic lah. So that boleh jalan. Better lah. Tapi kalau nak duduk kat situ pun boleh, tak ada masalah.
Nanti tukar-tukar slide pakai ni.
Ada semua. Saya dah testing dah tu. Semua dah testing. Okey dah. Pagi lagi saya nak testing. Mic tu belum tidur. Cuma nak mic tu nanti saya nak prepare bateri lah. Kena dia motor belum dulu.
Oh dia memang putih.
Untuk minggu depan saja. Ni ada 2 bar.
Yang semua dah okey ke? Nak dia punya apa tu? Layout macam ni. Apa macam dalam dia nampak ke? Ada nanti mana lah. Ni lah.
Nampak.
And other person kalau also put in their slide somewhere.
Yeah,
Is the other person?
yeah, they already put in.
Okay.
Yeah. And one, two, three. Oh, so kopi tu ada ni, ada tentatif je. Like yes, tak ada. Yes, ada dekat. Email ada. Kita buka. Apa? Nak sekarang tu? Tak, tu ada email. Email. Tak semalam. Maksudnya forward dekat saya. Tulis email saya. Zuhana.
Zuhana accepting. Yeah, I'm the one that was sending.
Oh, okay,
So
thank you.
I already put my bank.
Oh, yeah. Oh, outside. Oh, you don't want to put inside. Okay. Oh. But inside also packed already. Outside. Tak, yang satu page yang servis di sana ada. Yang satu lagi tu tentatif dah just saya dalam folder dalam Nano itu ada tentatif.
Yang PDF?
Betul.
Nak berapa?
Dia orang. Okay, we'll to start at 9:15. Okay, thank you.
At least you have a smooth run rather than you cannot check.
Dua minit je. Kalau kita kan nak tahu, and
Read them. The file quite big. Masuk. Mungkin cabut. Oh. For this one,
Because they connect with
ada online.
yeah, kita ada live YouTube for 30 minutes. So you tu selamat kot 30 minit. Yeah,
Ya, ya.
Opening ke?
Also first physical event for some time.
Yes, after 2 years, huh?
Yeah.
Unless she really wants to do that here, then yes. She next time. So all the
Lagi 4 minit. Ya.
Sedangkan pada
Rasa dia terkejut.
Going to start shortly. With that, I'll pass to Sri Berhad to lead our seminar this morning. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. First let's start our program with recite the doa surah Al-Fatihah. Amin. Senior Researcher from Sri Berhad, participant, distinguished guests, ladies and gentlemen. Alhamdulillah, we are gathered today for our National Symposium on Characterization and Processing of Nanomaterial 2022 in conjunction with Nano Kebangsaan Malaysia merakyatkan sains menginsankan teknologi. And it is my great pleasure and honor to welcome our distinguished guests and all participants. Ladies and gentlemen, now I would like to invite Mr. Abdul Rahim bin Muhammad Sahab for opening remarks.
Assalamualaikum dan selamat sejahtera. Ladies and gentlemen, it is my great pleasure and true honor to welcome all the participants, speakers and guest honors to the event in the National Symposium Characterization and Processing of Nanomaterial 2022, which is organized by Sri Berhad. This event conjunction with the Nano Kebangsaan Day started from 6 September to 9 September 2022. and participate in the program Nano Kebangsaan 2022, which is the prestige event conducted by NNC every year. I am very happy and grateful to see many participants from various, I think, from institution and industry to participate in this event, which maybe you all from the Klang Valley or maybe outside the Klang Valley in order to gain more knowledge. Opportunities of discussion between participant and expert to carefully balance the benefit of green nanotechnology and the potential cost for the society, particularly in terms of environment, public and occupational health for further investment and sustainable development of this promising nanotechnology field. Regardless, the same are doing our best to help to boost the government agenda, especially mostly to promote and enhance the nanotechnology in Malaysia through research and technology development. Which this calling, we encourage all the nano partners, clients, suppliers, vendors and our competitor to give up, not to give up, but actively try to come out which way to help our beloved program Malaysia in nanotechnology development. I am confident that with the new ideas, fresh energy and novelty to spark the nanotechnology in Malaysia. On behalf of the organizer, I wish you all excited and enjoy along the event that take place. Thank you very much.
Thank you, Mr. Abdul Rahim. Okay, ladies and gentlemen, today we will start the talk with the first topic from Jol, Malaysia. This topic will be presented by Dr. Rizwan bin Muhammad Rosnan. Allow me to read some of his biodata. Dr. Rizwan is currently a Senior Application Service Engineer in Jol, Malaysia, Sdn Bhd. He received his PhD in Physics. The title of his thesis Structural, Magnetic and Dielectric Properties of Nickel Magnesium Substitute Cobalt Ferrite Nanoparticles and Koshal Nanocomposite. He has 9 years of work experience in quality assurance in manufacturing and quality, safety and health in telco engineering before joining Jol, Malaysia. Currently, his specialty is in electron microscopy and analytical electron microscopy. So with his topic, the next level of analytical intelligence in FESEM, please welcome Dr. Rizwan bin Muhammad Rosnan.
So good morning everyone. Thank you for the organizer, Pusat Nanotechnology Malaysia, for the great event, and also for this organized ICI Advanced Material Stream, all the professors, researchers, students, friends, and everyone. So I would like to talk about PSEM. The next level of analytical intelligence of PSEM. The model will be a JSM, the IT800 SHL. Okay, so this model is a IT800 super hybrid lens SHL. So introducing PSEM integrating optical image, SEM image, and EDX analysis. So let me introduce you electron gun for this model. So this model is using an in-lens FE gun, field emission gun. So if you can see the comparison of the conventional model with an in-lens Schottky plus FEG. So all of them, by this design of in-lens Schottky plus FEG, all the electron will be can be used in the primary beam. So high beam current is available up to 500 nanoampere at 30 kV. So Joule will guarantee a lifetime for this gun is 3 years. So typical lifetime would be 5 to 7 years usage. So okay, with this is a thermal gun. So proper current stability very stable, about 0.2% per hour. Okay, if we compare with the 12 hours usage, so the fluctuation is very minimum. This is important, good for long-time analysis like GSR, HPA, hard particle analysis, and also e-beam lithography. Okay, for electron gun, it produces a high prop current. So by having this high prop current, this model may cover a lot of application field. So if you can see, just for example, here, like a cold field, the highest prop current is 2 nanoampere. So, okay, you can cover, limit your cover, your application, like SE, PSE, but maybe may have some disadvantage for other applications like EDS or WDS. Also, compared to the conventional thermal FEG gun. So by this model, we have a 500 nanoampere. It can cover from low current imaging up to high current analysis like WDS. So high prop current, good for fast analysis like EDS, mapping. EDS like a few seconds, and mapping in the minutes. Okay. So this is just to show the interaction volume simulation, because if you can imagine, if you use high kV, for example, like 15 kV, you may lose surface information. Okay, surface information that maybe that is your main purpose to see the contamination, for example. So by having this 15 kV, probably it will penetrate about 3 micrometer deep. So 90% of this deep will come from your others, like your volume, material volume, stuff, your holder, everything. Only maybe less than 5% is come from the surface information or contamination that you want to see. So the advantage is the advantage. If this model can operate from low prop current up to high prop current, I mean a low kV, low kV usage. So this is the advantage of low kV analysis. You can see from here, one is a 15 kV and another one is the right side is a 3 kV. So by right, you can see this is a much greater good spatial resolution for this analysis compared to this 15 kV. Some of the area may be saturated, and especially for aluminum and silicon. Of course, if you just refer it like a neighborhood in each element in the periodic table. So by having this low kV analysis, it simply can help you to eliminate, to segregate these two kind of element neighboring the periodic table. This is another example of ultra low kV EDS mapping. So instead of 10, 15 kV that we operate, so this operate observed in under 1.2 kV. So this is a zinc sulfide. Okay, proper current is only 5 nanoampere, but it can segregate or reveal the light element like the oxidation, oxygen element here. So this is a surface oxygen cluster detected first time at very low voltage, due to high current. Okay, due to high current and fine crop diameter at the 1.2 kilovolt. Okay, this is the aperture control lens, one of the good features, advantage for this model. So you can see, just to show you, this first and the second one is a common model in the FISM. So just to simplify it, if you just want to understand, if you use like under small probe current, so the crossover here, the electron is the upper position, meaning that only a small portion of electron pass through the OL. Then you of course you have a slim or small electron beam, but the probe current is lower. But if you want to increase the probe current, you may need to use a high probe current condition. But again, by having this high probe current, so the large portion of electron passing through the OL is higher. But because of this beam hitting too much on the specimen, become very large. Therefore, you will have some disadvantage of the image resolution. In the IP800 SHL, we have the aperture angle control lens. So patented ACM, we call it ACM. The focus, meaning that once it passes through the OL, so it will focus the beam just before enter OL. Thus, it can maintain the beam, maintain the high resolution even at high probe current condition. Okay, so this is the image for 50 picoampere and 500 picoampere. More or less is similar, but if you go to more high probe current, of course, a bit saturated image. Okay, but just to show you that either you go for imaging probe current and for EDS analysis, so it won't affect much on the image. You still can get high resolution image even for analysis. Okay? This example of a high spatial resolution EDS mapping. So you can see here, this is the AG nanoparticle. This surface on the titanium dioxide. So the kV they use is 5 kV, with the probe current is 2 nanoampere. Okay, checking in I think 9 minutes. Okay, what I want to highlight here is the spatial resolution, especially for this kind of particle size that we can observe in the mapping down to 20 nanometer size. Compare like a previous model past time. If you want to do EDS, you may need a high kV. So maybe 15 kV, 10 kV or 15 kV and above. So by having this high kV, your resolution might go to micron, 0.7 or 0.5 micron. So you impossible to get this high spatial resolution of mapping. This is another example, high speed EDS, meaning that see, good mapping with a high spatial resolution mapping. Okay, I will introduce you some detection system, so detector and objective lens for this model. So we have a UHD, upper hybrid detector. Okay, others is UED, upper electron detector. I will go one by one after this. Also backscattered, and our design of objective lens, we call a super hybrid lens. So okay, also we have a B mode, beam deceleration, and also we also have a low detector, secondary detector, to detect the information of topography. So I will go one by one. So this model consists, okay, this kind of detector, UED, UHD, FED, and BED. They also have an electron beam. They have a accelerated and decelerated inside the OL. This is the OL. So this is the figure for the OL. So you have a UED here. Just below here is a upper hybrid detector, backscattered bottom, and also low secondary detector. Okay, I will introduce you some for UED. So normally UED is like a filter. Okay, so they have an energy filter located just below UED. Okay, so UED able to detect either SE, a signal, or BE signal, or mixed by this both signal, SE plus BE signal. So what is the advantage if you have this kind of detector and signal? Okay. Okay, you see here, this is a UED. So they use electron bias, positive bias and negative bias. Okay, when UED, we put some positive bias to this. Electron that hit with and apply with positive voltage, what they have is we can collect both of SE signal and also backscattered signal. So for positive bias, UED will give you secondary image, secondary image. You may have a morphology image plus a bit of composition, But if you go for negative voltage, you give some negative bias to this detector. So the secondary will deflect because of the negative charge. With negative charge will deflect, but because of the this backscattered will have a strong signal, so it possible to collect by this UED detector become a backscattered image, and some of the deflected secondary will reflect and goes to this lower detector, like a lower secondary detector. Okay, so what you will have is like this. Okay, this is imaging. You will have the UED for secondary, for positive bias, and here is a negative bias for UED backscattered, 100% composition. Okay, and some morphology for this from a lower detector of secondary. Say this is a toner, then this is another specimen, AG CU specimen. Let's observe under 3 kV. So you can see the SED image, or even you can get this kind of backscattered more for composition. Okay. Just to have some introduction, I mean, normally secondary SE you will get more to morphology, signal, topography a bit. But if you go for backscattered totally composition, okay. But of course, they have a few option. I mean, from the backscattered you can get some composition, some topography, or some shadow, which means that like you can mix these two, some topographical effect plus composition. Okay, but backscattered will give you more composition. This is another example. Okay, this is a UHD, upper hybrid detector. So this UHD will use for a special resolution. So this is the detector. So this is an example of cerium oxide, osmium coating. This detector you can collect it. You can use without any beam decelerated mode. So you can observe very high spatial resolution observation. Here another example of Chichidawin. So you can see from low to highest. Just you see, observe very low kV, just 1 kV without being more. Another example, aluminum oxide particle. You see, very low kV, 0.5 kV observe. So by this kV, you can measure about 3 nanometer gap or 3 nanometer thickness. Others is aluminium. This is a 9 nanometer thickness, also using the UHD detector. Okay, this is an example of semiconductor. So I just highlight because this one is a tungsten. Okay, tungsten area. So we observe with the ultra UHD using a positive bias SE image. You can get some morphology here using an SE image. Okay. Sometimes morphology may give us some morphology effect. So if you don't have this kind of image, maybe you will judge that the tungsten become this thicker thickness, thicker. But when we switch to the backscatter image, then you can see 100% only composition. Only composition is revealed. Therefore, it will help you to see the exactly element tungsten here using a backscatter image. This one, another example is a cellulose, okay, using only 0.2 kV. Another detector that also available is a backscatter detector. This is one example, is a scintillator PSC detector. So by having this backscatter, you can see the composition image. Okay, this is composition image at low kV, and also you can obtain some dislocation image at high kV. We also have a versatile backscatter detector. This detector beneficial for 3D construction. Okay, they have a few segments here, outer segment of the detector, also inside. So you can see inside inner segment will give for composition, outer segment will give for a topographical segment. So by combination of this segment, they will generate a 3D image. Okay, 3D image. This is an example of microton cross-section of golf club shaft. So you can see using inner give some composition information by having different intensity, different contrast. Okay. Then also, if you only use the outer section, you will have a composition plus topography, meaning some composition but have some 3D effect, some topological effect. So you can see they have some topographical here. And if you use only half, then you will get only topographical. They will deduct the composition part. So this is in. Okay. This another example. They use mouse trachea. So by this detector, they can collect from all angles. Then we can construct it using a Smile View map, one of the software, our 3D software, or 3D analysis software. Okay. Okay, we have another mode. Like I mentioned before, it's a SHL. See, SHL, super hybrid lens, and also beam decelerate PD. So in standard mode, especially in a standard, you can do selected material, but limited to the magnetic or insulation material due to the magnetic leakage. Here, because if this is your objective lens, so they may have a magnetic leakage to this objective lens before it hit, so it will distort your image, distort your analysis and imaging. So in the IT800, we have electrostatic lens effect. It covers the end of this OL. So by having this electrostatic lens, there is no chance to have any magnetic leakage. The advantage is you can use magnetic or isolate sample to observe using this T-sample. So, okay. This electrostatic and electromagnetic field superpose objective lens. So this powerful lens enables to observe and analyze any specimen, including magnetic insulating material. And what is the beam deceleration? Beam deceleration will give apply some 5 kV bias maximum to specimen. Okay, by having this function, it will improve your spatial resolution and signal to noise, especially observed in low accelerated voltage, low kV. Okay, this is another example, good example for EBSD, Kittich pattern. So EBSD analysis can perform without any compromise, using objective lens without external magnetic field. If they have some external magnetic field, so this kind of a distort will happen. But IT800 will give a good EBSD pattern. This is a beam decelerate. So normally, what is a beam decelerate? This is like to understand. This is a normal beam from gun hit to the sample. Okay, so you may experience some charging effect. So by having this beam decelerate, so by right, the landing voltage will be slightly lower. Because of the stage, they give some bias to the stage. So you can see here, example image, easy to understand. So normal image, hard to get the imaging focusing or resolution. But using a GB mode, all the charging effect will disappear. Okay, charging effect and resolution will be improved. Same goes to here. It will reduce the effect of charging will be reduced by having this kind of stage bias. So this is without stage bias. This is with stage bias. BD mode, they call it BD. Beam decelerate. This is example, and this is a H class sample. We also can observe using this kind of mode. Okay, and also this is you can increase the bias voltage. By having increase the bias voltage will increase your backscattered signal, because backscattered need more energy to give a good contrast. Okay? This is an example of a 0.3. Even 0.3, you can reveal the contrast. And 0.3, 0.5. This is using backscattered, and this is using backscattered image, backscattered signal. Okay, just now I thought it's all for more to high vacuum. We also have a low vacuum mode, where this low vacuum mode will give you advantage, especially when you want to observe non-conductive sample. So how it works? So basically, we will introduce some gas, nitrogen gas. So now the idea is this positive charge of come from a molecular gas will ionize. When we hit with the incident beam, it will ionize, and which is neutralize the charge on the sample. So of course, the charge effect will be disappeared. So just to show you the system of this vacuum beam. This is from high vacuum example class. You have no chance to observe in a high vacuum because of charging non-conductive. Then you switch to the low vacuum. This model, they can go up to 300 nanoampere. Pascal, 300 Pascal, variable here. Adjustable, you can tune to adjust the vacuum in the low vacuum. So this is another example for low vacuum. Okay, they're using 7 kV, increase the Pascal one. This is the example of 150 Pascal. Okay, sorry, this is the backscattered signal. Then this is the low, LV, secondary detector signal. So you can make, you also possible to do mapping analysis. This is another example of option features we call montage. Okay, you can do a very large area of image. I will go through. This is a specimen exchange system. So either you can use draw-out system, or you can use a chamber lock system, okay, to maintain the high vacuum on the chamber. This is the features of our GUI. So we call a high throughput for daily usage. So you have EDS analysis, imaging SEM, and also they have data management in a smart lab. Okay, just to show you the live analysis, while you are having this kind of imaging, you also have a live spectrum monitoring for fast screening your sample. Observation, and also they have a real time of the EDS. This is a count map, and net map is how to segregate overlapping, to avoid overlapping between the neighbor element, like silicon and tungsten, titanium, barium. Okay, this is the net connect will help you to segregate the element, and from this data, switch convert to the only one click. What I call it, report. Easily report. It combined in one page. Okay, another function is like a live AI filter. This is more to visual enhance. We will enhance your signal ratio image from this is without, and by activate the light, it will give you a good quality of live image. Okay, saying this is a new engine because this new engine design will give you all automatic design. Start from beam alignment, all the focus astigmatism, and brightness, everything in auto mode. All is in auto. So this is another large depth focus. So meaning that you can use this to get image from taller specimen. And other attachment that you can attach to this also, like a soft X-ray emission spectroscopy. Okay, this is an example for chemical. Okay, so chemical state to differentiate the spectral shape, both this kind of a spectrum, by using a soft X-ray attachment. Okay, just this is the specification. 0.7 at 1 kV, or maximum 15 kV at 0.5 kV. So the magnification you can use up to 2 million. So this is the detector that we offer, and all the some of the specification here. Okay, so I think that's all for me. So anything you always can refer to us. Do not hesitate to contact us. Also, our team also here. Okay, and I think that's all. Thank you for your attention.
Thank you, Dr. Rizwan. So maybe if you can stay with because they need to set up to stop the actually they have a YouTube live just now, so they need to stop it. Maybe